Hello everyone, welcome to my channel Flip Flop Data. Today I will speak about consumer preferences and its associated model. So before I explain this in detail, let me ask you all something. Do you want to develop and launch a new product or service, or else get involved into enhancement of a product or service, but beforehand want to find out which attribute of product consumer values more to pull the right thread? So this video will explain in detail how this can be achieved. Let's dive into the topic map first. So what I will cover here is a short introduction of consumer preferences and the method used for the same. Second will be a case study discussion. Third will be Excel based design for developing the model. And fourth will be analysis and interpretation. So let's start with consumer preferences first. What is meant by consumer preferences? Consumer preferences are basically underlying foundation of demand. It refers to individual consumers' set of preferences and values whose identification and determination is key to increase ROI of business. So same is mentioned here in point 1 and 2, which says the tendency of consumers to like or favor something over other alternatives depending on the perceived utility of products or services. And the point 3 talks about consumers rating or ranking these products according to their levels of utility perceived. So, what consumer is always interested in is maximizing consumer surplus, which is nothing but value minus price, wherein the consumer is satisfied when their perceived value is greater than the price they pay for the product. That is, value minus price should always be greater than zero for them. On the other hand, marketers or the sellers, they get benefited when they maximize profit. That is, for them, price minus cost should always be greater than zero. Therefore, key is to provide highest value at lowest cost and right price. So how do we determine the highest value and right price for consumers is a big question. So in this scenario, consumer preferences play a very big role. A method called conjoint analysis is used to measure the same. So let me explain in simple terms what conjoint analysis is. So literal meaning of conjoint is joined together. And in marketing phrase, it is called features considered jointly, where con is taken from considered and joint is taken from jointly. So together it becomes conjoint. So here the product or service and their features as well as their labels are considered jointly to come up with a model to rate consumer preferences. So what we can define conjoint analysis as is it is an advanced market research quantitative method in order to understand how precisely consumers and markets value different elements of a service or a product. So let me elaborate on this. So this flow diagram depicts a clear view. So first and foremost step is deciding on the product or a service and to identify what consumers exactly want. Second is to break what consumers want into a combination of multiple attributes and its features. Then identifying the levels of those attributes or features based on which combinations can be created. Third comes is creating combinations and sharing it to users or consumers to rate those combinations on a chosen scale. Fourth is collecting those rated data with a check on quality. So, data collected should be unambiguous and consistent. Fifth is considering these rated combinations for analysis and interpretation. Then, sixth and the last is coming up with final preferences with the order of importance. So, while following these processes, we have few salient points to cater to. So, first, while selecting the attributes, we have to select it in such a way that all attributes are independent of each other. That is, no correlation should exist between them. Second is considering attributes with varying degrees or levels will be a good idea to gain maximum information. For example, if we take attribute color having three levels red, green, yellow, then that is the ideal one. Then, while identifying the levels, we should make sure to choose levels which are mutually exclusive. For example, if we are taking level yellow, it should not be expanded into light yellow or dark yellow or greenish yellow, etc., as they are more or less same with just little variation and overlap. Also, the levels chosen should be unambiguous. That is, if we care choosing popular, very popular, less popular, it does not convey any correct information, as popular for me may not be popular for somebody else. Then, after that, we need to look into the ideal number of attributes and levels to be chosen. So, minimum of 3 and up to 5 attributes are the ideal choice, because if you take more attributes, it increases complexity. Again, within those attributes, minimum of 3 and up to 5 levels is the ideal choice. Again, more level increases complexity, leading to compromised quality during data collection process. Then we have to choose balanced number of attributes and levels. That is, ideally, each attribute should have similar number of levels. Now coming to the design considerations. So suppose if we have three attributes with three levels in each attribute, the total number of possible combinations which can be created is 3 to the power of 3, which is 27. 3 is your attribute. Again, within each attribute, you have three levels. That is the reason 3 to the power 3. So you get 27 combinations. So we have two design options here. Either we can use full factorial design wherein all the above 27 combinations can be presented to each user or consumer for rating. Else we can use a subset of factorial design wherein we present subset to the user or consumer for rating. So subset is randomly chosen in such a way that they have almost zero to nil correlation, and each respondent should get equal number of subsets. So what I will use here is a subset of full factorial design and the rating scale of 1 to 10. This is done basically because it becomes very difficult for one respondent to rate on every combination particularly. And in such case, power to differentiate between one with the other combination becomes shaky. And he or she starts following her own heuristic rather than a properly sought out or thought out rating basically. So that might impact quality of the data which is getting collected. But one important thing to look at is while choosing the subsets, the subsets chosen should have an orthogonal design. This means that the chosen variables should not be correlated with each other, and they should have 0 to almost nil multicollinearity. So further I will show you how we can implement this method to find out consumer preferences. So let's start with our case study. Let us consider an example of a beer manufacturing company to understand the implementation. Suppose the company now plans to diversify into wine manufacturing, but beforehand wants to find out its consumer preferences depending on certain attributes. So, first is defining the product or service. So, our product or service here is wine. Second is we have to identify attributes and levels. So in this case, there are 5 attributes which are identified, and within each of those 5 attributes, 3 levels are created. Then comes the unique respondents who will be rating the products. So I have considered here 50 respondents for rating the products. And available design choices, as I told you earlier, is one is full factorial design, second is orthogonal design, and here we will be considering orthogonal design. So this is a glimpse of respondents and their rating, which is captured on a rating scale of 1 to 10. So next part is converting these attributes and levels into numeric representation, because this makes our computation easier. The correlation and linear regression needs numeric data. So the same representation of respondents and their rating has been given in numeric form. So what lies next is calculation of correlation between those attributes. I have just shown a calculation of correlation which shows that this is an orthogonal design which represents nil correlation between attributes. Here is one screenshot also attached which shows how you can compute the correlation. Basically, in Excel, from the data tab, when you click on data analysis, it gives you the option to select what kind of analysis you want to do. So here correlation has been chosen and the identified cells are considered. According to that, correlation is computed. In case you want to know how you can enable data analysis within data tab, then in Excel I can tell you the option. You can go to file, then click on options, then go to add-ins, then click on manage Excel add-ins, and then enable data analysis in the sheet. So this way it can be done. Then comes the linear regression part. So here linear regression has again been computed using Excel. So you can see the result, the coefficient, standard error, p-value, the confidence interval, everything is shown over here along with the ANOVA table. So wherever p-value has been mentioned as hash num, that is because the coefficients related to those p-value is actually 0. That's the reason p-value has not come up and it shows hash num. So again, there is a screenshot which tells you how exactly you can perform linear regression in Excel. Again, from the data tab, if you click on data analysis, it gives you the option to compute linear regression. You can choose linear regression, select the cells, and then compute it. Then here comes our preference model. So I will tell you in series of steps how from the linear regression results we can compute our preference model. So this is our first step. So in this table, beta coefficients or slope that is fully captured from our regression results. So regression results, going back, I can show you. Yes, this is the one. So all these coefficients for the corresponding features or variables have been captured, and that is represented in that table. So you can go through this. Second step again is calculating alpha coefficient based on beta coefficient. So how do we do that? Alpha coefficients are computed by subtracting sum of each of the levels of selected attribute divided by number of levels from the value in the corresponding cell as marked in the formula above. So let me explain you this. C10 is this. C10 is basically within attribute origin, the first level, we are considering this one, C10, minus sum of all these three levels within the origin attribute divided by number of levels. Number of levels is 3 over here for origin attribute. So we consider 3. That gives you the first alpha coefficient. Then similarly, you can compute the second one. Consider this second value C11 minus sum of C10 to C12, all these three levels divided by number of levels. This gives you again the second value, second alpha value. Similarly, you can compute this for the entire table. Then comes our third step. Third step is identifying range, that is high minus low alpha coefficient. How do we compute that? We compute that by subtracting minimum values of each level in the attribute from the maximum values of each level in the attribute as marked in the formula again. So let me explain you this. Here again what I have done is considering the attribute as origin, within that three levels I have tried to find out which is the maximum value. So maximum value is the first one, 0.33304, whatever. This is my maximum value. So maximum value within these three levels minus the minimum value, which is again this minus 0.20. When we subtract this, we get alpha coefficient. Similarly, for the second attribute, that is price per unit, we do the same. Identify the maximum value and subtract the minimum value from maximum value, and we get alpha coefficient. Then comes another step. Here final importance is calculated from high minus low alpha coefficient. How it is done? It is computed by summing up all the high minus low alpha coefficient values of all the attributes and dividing it by corresponding value in the cell, as again mentioned in the formula above. So how it is computed? I have my alpha minus high minus low alpha coefficient for origin as 0.54, which is E10. So this 0.54 divided by sum of all these uh, coefficients considered together. This gives me my importance. Then again for price per unit, considering zero point 0.7 as my value, that is E13, divided by sum of all these attributes gives me the importance value. So similarly, we can compute the importance value for all the rows. This gives me the final representation. So from the importance column, if you see the importance with the highest value is considered as the most important factor. So if we see here, our price per unit is the highest. So this is one of the most important factors to be considered, and how we uh, consider it here is consumers are very sensitive to price. Then second is origin. Then after origin comes aftertaste, and aftertaste comes glass, and the last is the calorie. So this turns out to be a very great way to represent consumer preferences, which is going to help the marketers in devising their strategy accordingly while placing new product in market to derive maximum ROI out of it. So with this, I conclude my first part. In the second part of the video series, I will show you how we can do similar computations using our language. Please post your comments and queries in the comment section, and I will be happy to respond. Thanks for watching. I will see you all in my next video. Don't forget to subscribe.